Alright, in this video I will be looking at permutations and combinations. So basically we've studied permutations, we've studied combinations, and now we're going to do problems where they're mixed up and we've got to decide, is this a permutation or a combination? Alright, so let's go ahead and get started. On number 1 it says for an 8-man basketball team, 2 different players will be selected for an award, one for MVP and the other for most improved. So you can see order matters here. And how many ways can this be done? Well, this is the number of permutations of 8 people chosen 2 at a time. That's 8p2. And we get 56. I'm just getting the answer off the calculator. Now, this can also be done using the fundamental counting principle. Remember, that's true with all permutations because we're choosing 2 people and order matters. For the first person, we have 8 people to choose from for MVP. Now that one person's been chosen, I only have 7 to choose for most improved. And so you can see either way we get 56. Alright, so with permutations we can always do those using fundamental counting principle. Letter B, if 2 players on the team are selected to be captains for a game, in how many ways can this be done? Now it doesn't say like there's a defensive and an offensive captain. There's just going to be 2 people that are captains. Order doesn't matter here. And so this is a combination, and it's 8 choose 2 since we're choosing 2 from the 8 and order doesn't matter. And 8 choose 2, we're going to get 28. So there's 28 ways. Here there were 56 ways. Alright, let's move on to number 2. For a recreational basketball team having 9 players, coach randomly selects 5 players to start the game. So in this case it's recreational. We're just trying to get everybody some playing time. So we're just randomly picking players. Order doesn't matter here. We're just picking 5 players that are going to play in the game. And so in how many ways this can this be done? We have 9 people and we're choosing 5. 9 choose 5, you get 126. So if you haven't already, I would encourage you to try to do the rest of the problems. And actually, I got to remember, you may not have all these problems. So I'll go ahead and put the bottom up there too. Alright, so let's go ahead and go over these. So hopefully you stopped the video and you tried them. Let's see how you did. So from a list of 15 books, students in a literature class must read 4 and submit an essay in which they analyze the book. And how many ways can the 4 books be chosen? We actually did one like this. This is 15 choose 4 because order doesn't matter here. We're just picking 4 books. We're not like putting them in order on a shelf or something like that. So here we have 1,365 ways. All right, number 4. There are 20 clerks in an office. At their company Christmas party, 5 of the clerks will be randomly selected to win 5 different prizes. No one gets more than 1 prize. So basically, once a person's been chosen out of the 20, they're no longer in the pot to be chosen again. Okay, well, since they're different prizes, order matters here. In fact, normally they'll give out the small prizes and then at the end they give out the best prize, or maybe the last 2 will be the best. Not necessarily, but they're all different. That's the thing. And so this is the number of permutations of 20 items taken 5 at a time. Order matters. That's because we have 5 different prizes. And so when you plug that into your calculator, you should get 1,800, 1,860,480 ways. Now remember, the other way to do this, you're making 5 selections, and so we can use the fundamental counting principle. For the first person, you have 20 people to choose from, and then there'll be 19 for the next selection on down. And so you can get the same thing by multiplying these 5 numbers out. All right, let's go to B. And how many ways could this be done if they all received the same prize? See, now order wouldn't matter. They're all getting the same prize. We're just picking 5 people to get a prize. So it's 20, choose 5. And you should get 15,504 ways. All right, last problem. Of 16 students at Brookhaven, 4 are randomly selected to fill out a survey. So you can see order does not matter here. They're just filling out a survey. It's all the same survey. So it's 16, choose 4. And you should get 1,820 ways. So we have 16 students. If they are finalists for a scholarship, where one $2,500 scholarship will be awarded and one $1,200 scholarship will be awarded, and how many ways can the 2 winners be selected? Well, order matters here. I want the 2,500. Order matters. There's 2 different scholarships. And so we're choosing 2 from 16. 16 choose, oh no, I said that wrong. We're choosing, this order matters here, so this is the number of permutations of 16 items taken 2 at a time. In this case, 16 people taken 2 at a time. And so you do get 240. Of course, the other way to do it is using the fundamental counting principle. You're picking 2 people from the 16. So the first selection, there's 16 people to choose from. Once that first prize has been given, there's only 15 for the next prize. And if you multiply that out, you do get 240 ways. And so that is it for this video.